this lesson takes a look at the transformation known as a reflection. And you might note this as a flip. Pause the video if you need to get all this written down. I'm just going to kind of talk you through it. The first thing that we need to remember about a reflection is that the pre-image is exactly congruent to the image. Now remember that that means that this transformation is an isometry. An isometry, again, is when we do a transformation but we have congruent figures. So this one would be an isometry. We're not changing the size or the shape, just the location. It is specified by the line of reflection, so you have to know that that line of reflection, where it is in order to do any of this. I'll just abbreviate that. Now you're going to see this in instructions sometimes just abbreviated. So you'll see a lowercase r, that's going to stand for reflection. And then you'll have a little note about what your line of reflection is. Maybe it's the line y equals 2, for example. Points that don't move. Any point that is on the line of reflection or on the mirror, like this one here in the grass, that point won't move as we do the reflection. So points that are on the mirror themselves stay on the mirror, just like Vegas. And then finally, it does change the orientation. So again, everything that was left is right, everything right is left, or up is down, down is up. Everything will be backwards in the reflection. All right, now most of our reflections are going to be across either the y-axis or the x-axis. We're going to pretty much stick with those. If anything changes, it's going to be one of these other common lines. Now, let's just review these really briefly. This line, diagonal line, y equals x, it cuts through all the squares right halfway through the quadrant, so the best diagonal you can get. In fact, this angle right here is going to be a 45-degree angle, if that helps you remember. Now, the other two lines that we'll use are the horizontal lines. Remember, horizontal, that's what that H right there stood for, horizontal lines. And this is to help you remember their equation. They are y equals equations. So this red line here, this is the line y equals, well, y equals what there? Y equals 6. So that's the equation of that line. The blue line down here is another y equals equation. What's y in this case? -3. And then Vux, and that's to help you remember that the V's there to help you remember it's vertical lines like the ones you see in the graph. And then the X is there to help you remember that they are x equals equations. So for example, this one here would be an x equals, looks like x is -8, just pull that off the x-axis. And then here in green, this is another x equals, and x is equal to 2 in that case. So we're going to stick with those kinds of reflection lines. We're going to look at a few rules, but before we do, I just want to show you that these reflections are really easier to just do by counting. So let's start out with this reflection. There's that indication that we're doing a reflection, and we're going to use the y-axis as our mirror. I'm going to take and I'm going to highlight my mirror here. That's what I'm reflecting this across. And this really is easiest if you do some simple counting. So let me show you what I mean by that. Let's take point A here, and we're going to reflect across this line by just counting how far away from the line it is. So point A is just, see how it's 1 unit away from the mirror? And so I'm going to go on the opposite side of the mirror, the same distance, so 1 unit from this direction, to find my new point. And this is called A prime. Remember that prime notation is to indicate that A has moved to this new location. We're going to call that point A prime. Okay, so do it with this one down here, point B. Point B here is how far from the line of reflection. How far from the y-axis? Let's just count that. It's 1, 2, 3, 4 units away. It's going to be exactly the same distance on the other side. So I'm just going to count out the same 4 units, 1, 2, 3, 4, to find my point B prime. So there's the image of point B. And then I'm just going to connect those up with a line, and that will be my reflection. So there's my reflection line. All right, so you're just going to count distances for the most part. All right, so what do they want us to do here? This R tells me they want a reflection, and the y equals x tells me the line they want me to use as the mirror. So this is going to take a pretty careful graph. Take your time and draw the line y equals x. You're going to have it going through the origin, and you're going to have it just kind of going right diagonally through each of the squares, hitting at every grid corner as it passes through each square. And make sure you come down also. You never know how far you got to go. So be pretty careful about that. So you should be splitting the squares along the diagonal right in half. And then you want to focus your attention 1 point at a time. Let's start with A. And if I'm counting this, It's a little bit tricky. Some of you are going to have a really good eye for it, and others you might want a rule. We'll hit the rule a little bit later in the lesson. How far from point A straight to that line? Now that means I'm going to have to also count on the diagonal. So let me just draw it out. This is on the diagonal. There's one diagonal. That's not very straight, but I'm going diagonal. So there's one diagonal unit, and then to get to the line to finish this off, there's two diagonal units. So I want to copy exactly that on the other side. Let me come out to the first one, just extending down. There's number 1, and here's number 2. So this should be where A prime is. So look at that again. From A to the line was 2 squares along the diagonal. And then repeating those same 2 squares on the opposite side gets me to A prime. So a lot of lines going on. Let's see what happens for B. How far is B from the slanted mirror? So on the diagonal count again, it looks like there's 1.5 diagonal squares. So I'm going to repeat 1.5. Let me take care of the half right there. And then to here, finishes off 1.5 on the other side. So here's B prime. Just connecting it up, A prime, B prime. There's the reflected line in red. All right, here is a little bit of a twist. We're going to find our line of reflection. And that's the line that just basically goes right through the middle. Here's original point J. Where's the image of point J, or J prime? There it is right there. So what's the line that goes right between the middle of those? Well, I'm thinking it's going to be about right here. You'll see how those are both the same distance away from that line. And let's see if that works out with these other points. There's E, and its image is right here. I think this is still midway. So it looks pretty good to me that this is going to be my line of reflection if I could do it straight. You really want to, all right, I'm starting over. You really want a straight edge for that. Let me do it with a straight line. How's this? Better? Better? Yep, that looks like a good mirror. All right, where is it over here? Find a point and find its image. Okay, you might start here with Y. There's point Y, and here's the image of point Y. So it's going to be halfway between these two. Let's see, how about right there? Does that look good? 2 units away from both sides. Let's find one more and make sure we're right on this. Here's U, and U prime's down here. So go halfway between U and U prime. You're right there. Looks like that's a line on the mirror. Let's draw this in. There we go. So it's a horizontal one. So those are the 2 lines of reflection. Now I'm going to go back because we do need to write down the equation of these lines. So let's start with this one. This is a vertical line. So I'm thinking Vux here. This is going to be an x equals equation. The equation of that line would be x equals what number? Well, let's see. Here's the origin right here. So it looks like it's 1, 2, 3. This is x equals 3 there. All right, on this graph, this is my line of reflection. That's a horizontal line. So now I'm thinking to help me remember that it's a y equals equation. And what's our y value? Again, here's the origin where they're crossing, so that's just one below. This is going to be y equals -1 is my line of reflection. That's how you do that. As we wrap up this lesson, we're going to look for some general patterns, some rules that we can come up with. Truthfully, it's going to be easiest most of the time to just count to get these reflections. But if you need a rule, let's build one. Looking for a pattern. Okay, we're going to do x-axis reflection. So remember, this is your line of reflection right here. Let's take A across the x-axis by counting. It's 1, 2, 3, 4 units to the mirror. So come on the other side 4 units and put your A prime right there. And let's put in our table here our image point. It looks like it's at -1, -4. Okay, let's take B. B is right here on the x-axis. If I reflect across the x-axis, yeah, that guy's not going anywhere. B is already on the line of reflection, so it stays right where it is. That was our property. And C. Take C across the x-axis. Right now it's 2 underneath, so 2 above it's going to put it right here. So C prime has the coordinates 1, +2. And we're looking for a general rule. What happens from A to A prime? How do these coordinates change? I hope what you're seeing is 2 things. First of all, tell me about what happens to X. That X coordinate looks like it's staying exactly the same. So X stays just as it is. X stays the same. What's happening to Y? Look at your Y's, you guys. I'm going to highlight these babies. Look at what they used to be. Look what they are now. Same number, just different sign. Our Y values change their sign. We call that negating it. All right, so here's your mapping rule. The rule is this. You take your original X and Y coordinates And you map them or convert them into new coordinates by letting x stay the same, so it's still x, but you're going to change the sign of y. We say we're negating the y. Of course, if it's already negative, that means it's going to turn to positive. So that's how you do your mapping rules for the x-axis reflection. Let me just grab my line here, and I'm going to draw in this reflection. We can take a look. So there's A prime, B prime, C prime. And you probably want to go back and note here that B is exactly the same as B prime. Okay, do you see that reflection? Hope so. Let's do a y-axis. And the same kind of story. We're looking for a pattern. This time the y-axis is our mirror. So starting here with A, we'll just flip it across, take it 1 unit over on the other side. Put down your coordinates of A prime. And I'm seeing what's 1, 4. B is going to come across the mirror, across the y-axis. It's 2 units away, counting it. So 2 units on the other side for B prime. And what's the coordinates at this point? It's -2, 0. So let's write that in our table. And let's finish it off with C prime. C is just on the other side of the y-axis right here, 1 unit away there. So our coordinates for C prime are -1, -2. All right, well, I'm grabbing the line tool. I want you to look for your pattern. So here's our reflection, A prime, B prime, C prime. And let's see if we can find a rule here. So what happened? Look at your x's. Are your x's any different than they were to start out? Yeah, there's this pretty significant difference in those x's. They're all the same number, just different signs. So here we're negating our x's. Let's write that down. So the x's change sign. And what about the y's? Looks like our y's are exactly the same. So the y's stay just as they were, stay the same. Okay, so to write that as a mapping rule, again, I'm going to take my x, y, these are my original x, y's, and convert them according to this rule. For x, I change their sign, negate it, and y stays just the same. Okay, so that's x-axis, y-axis. I seriously think you should just count these. Don't worry about memorizing these 2 rules. All right, last one. Now, of all these rules, this is the only one I might memorize, and this is our slanted line of y equals x. So if you want to memorize a rule, you might have an easier time with it. Let's start out by getting a really great line of reflection. So you want to graph this. Your line y equals x, remember, start here at the origin and bring it out diagonally through squares. Come up all the way. And you better come down also. So let's come back to the origin and let's go back the back door here. Diagonally through those squares. Whoa, I don't know what happened right there. That's kind of psycho. Get rid of that. Okay, just ignore that. Can't get rid of it. All right, so we're going to reflect across that line. Let's take our A prime to start out. Notice this one's pretty easy since it's sitting right there on the line of reflection. It's not going anywhere. Stays right where he is. And let's just put that in our table. So A prime is still at 2, 2. B, however, B is going to head to that line of reflection, and we're counting on the diagonal how far to the line from B. So on the diagonal, 1, 2.5. Repeat it on the other side. Let's take the half and then go out 1, 2. You should have your point B prime right here. And where is that? X is 3 and Y is -2. So let's jot that down. 3, -2. Okay, let's see what's happening with C prime. So C right here, let's count on the diagonal. Count 1.5. Come back out on the other side. There's a half and then to 1. So there's our C prime, and what are its coordinates? -1, -4. All right, I hope you're starting to see a pattern here. -1, -4. If you see a pattern in how all these image points came from our original, then why don't you just write down what the coordinates of D prime are? D prime, what are they? Well, I'm counting that. You jot it down. All right, so here's D, and it's 1 on the diagonal. Start over 1.5, come out half and 1, and there's D prime. Okay, so it's got coordinates of 2, -1. Hopefully you already knew that. If you see a pattern here, then what is it? Pause the video, jot it down. Okay, before we get too far, I'm going to draw in my new image. Here's A prime, B prime, C prime, D prime. And there's a cool reflection for it. What's your general rule? Let's highlight the x values, and notice over here that same list of numbers right here in the y values. And it is not a coincidence. Here, look at these y values on the original. They are now the x values. So how can we say that? We can just write that this way. We're basically saying that we're going to switch around the x and the y coordinates. Switch your x's and y's. So what used to be x, y in all of your points is mapped over to a yx coordinate. You're just going to flip them around.